is Mammoth Math, Algebra 1 placement test, part 1, yes. Mammoth Math is something that I found online that I thought was a good, comprehensive assessment that covered all the Algebra 1 content that I felt you should need. It's got some good stuff, very, very thorough, very, lots of different types. So let's start, and they break it down and they do a very good job of telling you what they're assessing. So we're going to start with exponents and scientific notation. No calculator is allowed. Find the value of the expression. I love this problem. I love this starting problem because this is a tricky problem. This says the opposite of 2 to the 4th. You need to understand that your exponent and your base, your exponent is 4, your base is 2. Your base is not negative 2. The negative comes after because we do exponents before we do anything, before we do multiplication. So we would do 2 to the 4th and then we take the opposite of 2 to the 4th. So in actuality, this says the opposite of 2 times 2 times 2 times 2, or negative 16. So we do this, which equals 16, and then we do the negative. Very, very important. Really great question to open the game. Here we have, and now we hopefully see the difference. Here is our exponent, but this time, because Chewbacca's here protecting and pulling in the negative with the 2, now we have a base of negative 2, and we have that 4 times. So this will produce a positive 16. When we have 4 negatives, it ends up being positive. Here we only have 1 negative, and we have 4 2's. Completely different question. Really, really good. Love that they call this. Now this negative, completely different aspect. This is the exponent is negative 2. What does negative 2 exponent represent? It represents something, an excess in the denominator. So our base is in the numerator. So we would understand that if we want to change this exponent from negative to positive, we change where the base is. The base here is in the numerator, but if we put it in the denominator, if we change its location from numerator to denominator, we change the exponent, the sign of the exponent. So this equals 1/49th. We also could say it equals the reciprocal. So if you take the reciprocal, you change the sign of the exponent. So another way to see this, to recognize it, 7 to the negative 2. So if we take the reciprocal, we would change the exponent from negative to positive. So that's another way, and then we get 1 squared over 7 squared, or we could see it as 1/7 times 1/7, which again is 1 squared over 49. So a lot of different ways to look at that. Really important for you to understand each aspect of what is going on there. Here we have like bases, and so we know that we can use the exponent, product of exponents. When we multiply like bases, what do we do with each of their exponents? We are going to add those exponents together. So that becomes 6 to the 3 plus 8 plus negative 9, which is 6 to the 3 plus 8 is 11 minus 9, which is 6 to the 2nd, which equals 36. Another way you can look at it is 6 to the 3rd times 6 to the 8th times 6 to the negative 9th. You wouldn't want to do this. This takes way too much time, but that's 6 times 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 6, 1, 2, 3, 4, 5, 6, 7, 8 times, now 6 to the negative 9th is 1 over 6 to the 9th. So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be the same as taking that, and then we cancel. 1, 2, 3, 4, 5, 6, 7, 8, 9. Look what we're left with. 36. Who wants to do that? That is very, very inefficient. I would tell you not to do that. Always use this. Way more efficient. We have 31, find the value of the expression. So this is 31 times 1 over 10 to the third, which equals 31 times 1 over 1,000, which equals 31 over 1,000, which you wouldn't want to do. You would just understand that you would move that decimal over, so we can find the value of the expression. 31 1,000ths. So what does that look like? Tens, hundreds, thousands. That would be 31 1,000ths, tens, hundred, thousandths. And you end in that place value. So that is equivalent to 31 over, right? If we convert it to a fraction, these are identical, 31 over tens, hundred, thousandths. That's how I would do it. 10 to the fifth plus 10 to the fourth. We cannot combine like bases because we have addition. So that is 10, that is a 1 with 5 zeros plus a 1 with 4 zeros. And that gives us 110,000. Negative is not the exponent. This is negative 2/3 times negative 2/3 times negative 2/3. This is the long way about going it. That is negative 8 over 27. The better way is to distribute this 3 into the exponent. You would write this with parentheses. You're distributing. And negative 2 to the third is negative 8. And 3 to the third is 27. That's the much more efficient way. Make sure you notate with the parentheses. 4 to the 10th divided by 4 to the 7th. We would do 4 to the 10 minus 7. The division, the act of dividing like bases, is subtraction. We have like bases, and we have the exponents of 10 divided by 7, and that's taken with subtraction. And that gives us 4 to the third, which equals 64. And we could look at this 4 to the 10th. This is going to be very long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1, 2, 4, 5, 6, 7. And notice, we have 7 in the denominator that's going to cancel with 7 in the numerator. 1, cancel, 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 cancel. Those are all 1s times each other, which equals 1. And then we're left with 4 to the third, which equals 64. So we wouldn't do that. We're subtracting 7 from 7 in the top. That's why the division of like bases is subtraction. Here is very interesting. Here's important notation again. We can distribute exponents through multiplication and division. We cannot distribute exponents through addition and subtraction. So properly written, that would be that. And negative 2 to the third, as we already know, is negative 8. S to the third. So that's how we would do that. It doesn't behoove us to write that. That's just too much work. We should utilize the laws of exponents, power of a power. And so we distribute it into that. We can, again, distribute it to each of the pieces. That's 12 to the second times x to the second, which is 144 x to the second. Super easy. We're going to have a power of a power this time. This time we have 5 of these bases. The base, so we have the exponent, we have the base, and that base is 1 to the third. Now, it's not productive for us to do this. This is too long, but I'll show you how many of these do we have. We have 5 of those. So that is y to the 3rd times 5, which equals y to the 15th. Much easier to do this understanding that a power of a power, we multiply their exponents. And if we added all those up, we have 3 adding itself 5 times, which is 3 times 5. Nothing can be simplified. Nothing needs to be simplified. So now we're going to multiply like with like. We have 2 times negative 3. We have like with like. So we have x to the 6th times x to the 2nd. So 2 times negative 3 is negative 6. X to the 6th, like bases, multiplying, we are going to add their exponents. So we get negative 6x to the 8th. You do coefficients with coefficients, like bases with like bases. This is a distribution. We're going to multiply power of a power. This is negative 3 times 2, which is y to the negative 6. Now, we are not allowed to have negative exponents, so we are going to change the sign of the exponent by moving the base into the denominator, 1 over y to the 6th. We're going to distribute, or remember how we can also get rid of that negative is taking the reciprocal. If we take the reciprocal of 4v, that would change it to a positive exponent. That changes the sign of the exponent. And then we understand that we have 1 squared. We're going to distribute, distribute, distribute. 4 to the 2nd, v to the 2nd, which equals 1, 16v to the 2nd. You also could have seen it as 1 over 4v times 1 over 4v. That's slower, more time. Not utilizing the exponent rules, properties of exponents. So nothing can be simplified inside the parentheses, so we're going to go and distribute that square to each one. 7 squared times x squared over 3 squared times y squared. Each of the things inside get that squared. That's 49x squared over 9y squared. All of this is about efficiency. This is an interesting one. It's not often that I want you to write a -1, but in this case, it's not a bad thing. Okay, now it's to the 3rd. So we can rewrite this. It just helps us see the distribution. I would simplify this before I distribute the exponent. I would do the grouping symbols before the exponents. Remember, orders of operations says grouping symbols, exponents, multiplication, division, addition, and subtraction. So I have a grouping symbol where I can simplify, and that's -1. X to that, we're dividing, so that's 2 minus 1, 2 minus the 1 in the denominator, all over 5 to the 3rd. That can be simplified. -1 x over 5 to the 3rd. So this all simplified to that. 2 minus 1 is 1. We're not going to write the 1 there. So now we're going to distribute the cube. So we get the quantity of -1 cubed times x cubed over 5 cubed. -1 to the 3rd power is -1. X to the 3rd over 5 to the 3rd is 125. How do you know all these squares and cubes so easily, Mr. Mac? Because I do the work. So this is an acceptable answer. I don't mind that. This is an acceptable answer. I love this. I like this. This is more high school. That's more of a, that's not a very good more. That's more of a high school answer than this. We don't like writing -1x. That's not something that's frowned upon in high school. That is the proper answer. You also could have written x to the third over negative 125. That's okay also. So either of these are better answers than this. It's acceptable, but that's a technicality, so keep that in mind. We're going to distribute. There's nothing we can simplify inside, so we're going to distribute 3 to the fourth, b to the fourth, c to the 5 times 4. 3 to the fourth is 81, b to the fourth over c to the 20th. Ooh, that's a big number, and that is fine. Write numbers in scientific notation. My decimal point currently sits right here. Scientific notation is when your number is between 1 and 10. It has to be greater than or equal to 1 and less than 10. It has to be a single digit in the ones place. So right now, that number is not between 1 and 10. That number is not between 1 and 10. If I move it one place, is it between 1 and 10? No. It's now it's 19,300,000. Now what is it? Now it's 1,930,000. Now what is it? If I move the decimal, it's 193,000, 19,300, 1,930, 193, 19.3. Close, still not between 1 and 10. Now if I place the decimal point here, that new number is 1.93. And that number is between 1 and 10. Now, I need to represent this clearly is not equal to this starting number. These are not the same. They have to be equal. We're just rewriting. How can we rewrite it? Well, for every place value, we value it a 10. This is a tens place. Makes sense. That's a tens place. That's a tens place. Oh, Lord. That's a tens place, etc. Sorry, telephone. So 1, 2, 3, 4, 5, 6, 7, 8. Those are 8 tens places. So that's 10 to the 8th. So our answer in scientific notation is going to be 1.93 times 10 to the 8th. Always, we know that that number's decimal place is there. It always is there. And then we put it there and then we move it until it's between 1 and 10. This is equal to this. This is equal to this number. Okay, we just wrote an equivalency in scientific notation. So let's write our dot. Let's move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. When we move it here, that number becomes, and it's times 10 to the 12th because we moved it 12 places. Now we're going the opposite way. So when we move this decimal, now we see the decimal. When we move it, it's still not between 1 and 10, still not between 1 and 10, still not between 1 and 10. Not until it gets there, 4.6 times 10. Now, moving it backwards is going to be negative or 1/10 of a thing, because 10 to the negative 1 is equal to 1 over 10, or a 10th. So we're moving it a 10th place. So how many times did we move it? We moved it 1, 2, 3, 4. So that would be 4.6 times 10 to the negative 4th. We get our decimal point. We're going to move it. Is it between 1 and 10? No, 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 no. It's not even between 1 and 10 there. That's 0.9. That's not between 1 and 10. We're going to move it to here. So that new number is 9 times 10 to the 1, 2, 3, 4, 5, 6, 7, negative 7th. And the other way that I explain it, another interesting way, is this is a big number. This is a really big number. This is a small number. Well, where did the bigness go? You can't just make a big number small. It has to be represented somewhere. And we know that 10 to the 8th is a big number. That's 10 to the 8th. 10 to the 8th equals a 1 with 8 zeros. That's a huge number. That's a big number. So where did the bigness go? If we squish this down, here's where the bigness, this is a big number and this is a small number. So where did the big go? The big is represented here. Same thing with a small number. This is a really small number. This is a very small number and we made it bigger. So where did the smallness go? Here's the smallness. The smallness is right here. 10 to the negative 4 is equal to 1 over 10 to the 4th, or 1 over 10,000. So this is, the smallness is represented here. So important. Not a lot of people teach it in that manner, but the Earth's mass is 6.0 times 10 to the 24th kilograms. Neptune's mass is 1.0 times 10 to the 26th. What fraction is the Earth's mass of Neptune's mass? So what fraction is the Earth's mass of Neptune's mass? So we have 1.0 times 10 to the 26th divided by 6.0 times 10 to the 24th. I'm almost certain that's what we need to do here. I flipped it. My bad. We want to do the Earth's mass divided by Neptune's mass. Sorry. So what we can do, what we're allowed to do, is we're allowed to take the constants, the exterior numbers, and divide those like numbers, like constants. 6 divided by 1 equals 6. And then we're allowed to divide like bases. We have division of like bases. So we're going to do 10 to the 24 minus 26. Division is subtraction. This becomes 6 times 10 to the negative 2. So what fraction is 6 to the negative 2? Don't know if that's the answer that they're looking for. Or the very, nope, they want even more. So this equals, if we had to convert this to out of scientific to standard, we would move this decimal 2 places to the left because we have to represent the smallness. That's small. So that number is 0.06. That is 6 over 100, which equals 3 over 50. So 3/50ths of Neptune's mass. Of Neptune's. That's the fun way of doing that. So not the most logical way to do it, but it works. One gold atom weighs about 3.3 times 10 to the negative 22 grams. That's really small. How many gold atoms are in 99 grams of gold? So if there are 99 grams, this is 1 gram. So we're going to multiply that. 33.3 times 10 to the negative 22. So if we multiply that, we're going to get, we're going to divide again. 1 gold atom weighs that grams. How many gold atoms are in 99? 1 gold atom weighs, oh, sorry. Yes, sorry. We're going to divide. So if we have 99 grams and each atom is 33.3 times 10 to the negative 22, how many of those little ones are divided into that? Yes. We're going to do it in that fashion. We're going to see how many atoms can be in there. So we're going to deal with our constants like a traditional division. No calculator. So let's see how we do this. Watch this. When we have 99 over 3.3, we're going to move that decimal point. If we move it in the denominator, we have to move it in the numerator. That makes 990 over 33. 11 goes into this. 33 goes into this. 33 goes into it 30 over 1, or 30 times. So this yellow equals 30. And then we're going to deal with the like bases. And we are dividing, so we're going to subtract. So we have 1 minus negative 22. Sorry, this is times 10 to the 1 minus negative 22, which becomes 30 times 10 to the 1 plus 22, which equals, let's move this over a little bit, group of that. This becomes 30 times 10 to the 23, but this is not in scientific. How many? It doesn't say to put in scientific, but it should be. So your decimal is currently here in 30. So we'll move it one place, and we get 3 times 10 to the 24 atoms. That's the best answer. Don't know if they do it to the 24th. Now, what? 23rd? How did they get 23rd? That's 3. What? Grams, that's right. Why did they get 9.9? 9.9, that's grams of gold. That should be, that's wrong. Their answer is wrong. It should be 99 times 10 to the 1. How many gold atoms are in 99 grams? And this is in grams. No, my answer's right. Theirs is wrong. They made a mistake. Irrational numbers. Let's see if we can get a couple of these done before we have to turn off our video for part 1. Plot the following numbers approximately on the number line, no calculator. So we want to look and see what is the value. What are all these approximation? Negative 2 rad 2. So where is rad 2 on the number line is really what they're asking. So if we have rad 1, that equals 1. Then we have rad 2, rad 3, and rad 4. Rad 4 is our next perfect square. So rad 2 has to be somewhere between these. So it's greater than 1, but less than 2. So it's a fraction between. So it's got to be between 2 times 1 and 2 times 2, if this is more than 1 less than 2. So that's going to be somewhere between here, between these two, between negative 2 and negative 3. That is going to have to be somewhere between there. Now, if you were going to err on the side, I'd probably err on the side of between negative 3 and negative 2, because where would rad 3 be? You know what I mean? So I'm assuming it's going to be somewhere in between here. So I'm going to say that this value, we'll do it in color, is going to be somewhere like here. I think that that's fair. Rad, let's do some other, no, yeah, they're all radicals. All right. So now let's look at this one. Rad 82 over 3. I'm assuming the radical is not on the 3. So 82, well, rad 81 is going to be 9. So rad 82 is going to be more than 9. So that's going to be something like 9 and change over 3. So this is going to be approximately 3, or a little bit more than 3. So I would put this at a little bit more than 3. I don't know what you say, but I kind of like that. Let's take negative rad 10. So where does negative rad 10 sit? Well, we know that rad 9 equals 3, so rad 10 is, and it's negative rad 10 is negative 3, so negative rad 10 is going to be a little bit more than 3. And then negative rad 16 would be 4. So this is going to be negative 4. So that's going to be negative 3 point something. So we're going to put this a little bit more than negative 3. It's going to be between negative 3 and negative 4. Okay? Rad 35 minus 1. So let's look at that. Rad 35, where does that sit? Well, rad 36 would be 6. So we know that's going to be 5 and some big number. It's going to be like almost 6. So if we do 6 minus 1, that gives us 5. But we don't have 6, so it's going to be 4-ish. More in the 4, high 4 numbers. So let's do this color. So let's put that in the high 4s. So it'll be something like that, somewhere in that area. And then let's look at the last one, rad 8 plus 3, rad 8 plus 3. So again, rad 8, what if we had rad 9? That would be 3. So rad 8 plus 3 is going to be a little bit less than 3. So 3 plus 3 is 6, so it's going to be a little bit less than 6. So this provides us, let's do this one. So this will be a little less than 6. So those are your 5 values. Really good problems, very, very good practice in understanding radicals and their values. We know that all radicals are irrational, meaning, not all non-perfect square radicals are irrational. And what I mean by that is if you take the square root of 2, you're going to get a non-repeating, non-terminating number. So we can't write that decimal form for the value. This is an approximation. The only value that is exact is its radical form. So good luck. This is part 1, and we will continue with these problems. Our next part is going to be placing those irrational numbers in their groups. The next section, which is, or not next section, is continuing on irrational numbers. And just as much as this was a really good activity to understand radicals and their values and their place on a number line, this activity is equally as important. And you should take the time to sort of be able to place numbers and see where they are in the sets of number sets. And so we'll start with the first one. Sorry, highlight. Let's take 9. 9 is a whole number. So 9 would go into the whole numbers. Whole numbers are include 0, so 9 is in there. Negative 109 is considered an integer. So whole numbers, integers are whole numbers and their opposites. So that would be negative 109 would be in the integer location. 3/8 is going to be a rational number, 3/8, because it's not a whole number or an integer. Sorry. Let's do this. 13/8. Sorry, I said 3/8. 13/8 is going to go in for rational numbers. Those are fractions that do not simplify to a whole number. Rad 3, we know what rad 3 is. Rad 3 is going to be an irrational because it's not a perfect square. So that's going to go here. And that produces a non-repeating, non-terminating number. It goes on forever and it doesn't repeat. Square root of 49, however, is a whole number. So that is a whole number. That's going to go in here also because that is a perfect square. So perfect squares, square root of 49 equals 7. Those are whole numbers. 7 is a whole number. 2 pi is going to be irrational. Do you know why it's going to be irrational? because pi is irrational. It is non-repeating, non-terminating. So any number that can't be written as a fraction is going to be irrational. Well, Mr. Mack, can't you write pi as 22 over 7? Yep, but that is an approximation value. 3.14 is an approximation value. Now let's go with 7.89. That's going to be a rational number. We'll make that blue because you can write that as a fraction. It's not a fun fraction. 7.89. That's a horrible. 7.89 is 7 and 89 1/100th. So that would be a rational number. 0.41 repeating, that also is a rational, but it's repeating. Exactly. It's not non-terminating. It terminates. Well, excuse me, it is repeating. It doesn't terminate. It goes on forever, but it can be written as a repeating decimal. So repeating decimals are considered rational because we can write this as a fraction. I don't know if you know that. That can be converted. In fact, I think there's a problem later on coming where we have to convert partially repeating decimals into fractions. So we'll go over that a little bit later, how we get rid of those and write it as a fraction. 400 over 8, the square root of 400 over 8. Square root of 400 is a rational number. That's going to be, that can be simplified to 4 times 100, so that's 2 times 10, so that's 20 over 8. But 20 over 8 is a decimal. It doesn't simplify to a whole number or an integer, so that's going to be in the rational numbers also. 400 is a perfect square, so 400 over 8, but it's not a whole number. It produces a decimal. 0 is a whole number, so whole, notice the O in whole, that's why 0's in the whole number category. 0, let's make that yellow. Negative 4/9 is going to be a rational number. A lot of rational numbers for us. Negative 4/9, it is a repeating decimal, but negative 4/9 we'll put right there. It's not a whole number, it's not an integer, it is a rational number. Rad 2 plus 1, we know that all radicals that are not perfect squares are going to be irrational. So we'll put that right there. This is rad 2 plus 1. Negative 35 over 7, that can be simplified to negative 5. So that would be considered an integer. So an integer, because this can be simplified to negative 5. Negative 35/7. 5 over square root of negative 11. First of all, there's some couple bad things about that. You can't have a radical in the denominator. Plus, that radical does not simplify, so that will be irrational. So 5 over square root of 11, and the square root of 900 is square root of 9 times square root of 100, which is 3 times 10, or 30, and 30 would be a whole number. So 30 is going to go there. That's going to be yellow. That's yellow, and that's yellow. So not bad. Hopefully that gives you a little bit more structure of understanding these sets of numbers. Whole numbers, integers, rational numbers, irrational, and then every number is considered a real number, whether it's rational or irrational. Good. All right. Solve if the answer or answers are not rational. Give them in root form. So what is the inverse of squaring? We want to get the variable by itself. The inverse of squaring is taking the square root. So the square root and the square cancel each other, but whenever we take the square root of a variable being canceled, we have to introduce plus minus. So it's plus minus rad 54. Now, rad 54. We want to simplify, and that does not simplify. That doesn't simplify. There's no factors of 54 that are a perfect square. So my solution is going to be plus minus 50 rad 54. If it had a perfect square as one of its factors, then we would be able to simplify it. Sorry, that temperature is pretty cold. Let's isolate first. We always have to isolate the variable prior to taking the square root. That gives us n squared equals 147. 7 plus 1 is 8, plus 4 is 12. So I know that 3 goes into 147. So 3 goes into 14 4 times, with 2 left over, and 49. So 147 over 3 simplifies to 49. I'm going to take the square root of both sides in order to get rid of the square. Whenever I take the square root of a variable being squared, I'm going to introduce plus or minus. N equals plus or minus 7. That would be my solution. And that is the answer to that. Cube. So what gets rid of a cube root? A cube, I just answered it, is a cube root. So we're going to take the cube root. You have to write a 3 in there. And that leaves us with z equals what number multiplied by itself 3 times is going to give you 64? 4. It is not going to be plus or minus, because if it was minus, if it was negative 4 to the cube, that would produce a negative 64. So when it's an odd number, we don't include plus or minus. When it is an even number, we would introduce plus or minus. Okay? Write the repeating decimal. Here we go, as a fraction. So there's a couple of ways. There's some tricks. Let's talk about the trick. The trick is 0.8 repeating is going to be 8 over 9. 0.4 repeating is going to be 4 over 9. 0.3 repeating is going to be 3 over 9, which simplifies to 1/3. And yeah, of course. If we have 0.24, now let's do 2, 3 repeating. Both terms, both numbers have to be repeating. That's 23 over 99. 0.17 repeating is 17 over 99. If you have 0.18 repeating, that's 18 over 99, which can be simplified to 6 over 33, which can be simplified to 2 over 11. And if we do this, 2 over 11, 2 divided by 11, we notice that we get 18181818 repeating. So that's a nice trick. So I don't have to use the other technique. So 0.71 should be equal to 71 over 99. If there's 2 things repeating, 2 9s. If there's 3 things repeating, 3 9s, 4, etc. So the number of digits repeating are the number of 9s that you put in the denominator. So 71 over 99 is going to be your answer. Now, there is a more technical way to do it. And it's not that it's applicable to this. It's more applicable, I believe, because I would use this trick on any, let's clone the page. Let's erase, clear the ink. I wouldn't use this, but I'm going to show you. You create an equation, you say x equals 0.71717171, etc. And then if you multiply the left side by 100, you get 100x. And in order to keep it balanced, you would multiply this right side by 100, which would give you 71.71717171. And then you want to subtract both of those. And the subtraction is nice because it cancels out all of the repeating components. And when you get to here, you get 71, okay? Equals 100x minus x is 99x. And now we divide by 99, and we get x equals 71 over 99. That's the way to do it. Now, I would not use that technique. I would use this technique for any repeating decimal. When we would use this technique is if we saw a problem like this. So let's do this. If I saw the problem 0.18 repeating, that partial repeating, remember when we went back to this, remember how I mentioned this 0.41 repeating? Let's do that one then. We'll do that example. Okay, so let's use that 0.41 repeating. So if we set x equal to 0.41, repeating 1, 1, 1, 1, and we multiply it by 10, because there's only one thing, 10 equals x. And if we multiply it by 10, we get 4.111111, dot, 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 dot. That goes on forever. So all the ones down here cancel, 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 cancel. Now we got to borrow. And 4 from 11 is going to give us 7. And 3.7 equals 10x minus x, we're subtracting, 9x. So we divide by 9, we get x equals 3.7 over 9. I can't have a decimal, so I'm going to move. If I move it in the numerator, I must move it in the denominator. And it gives me a final answer of 37 over 90. So that's why that double 9 doesn't work when it's only part of the decimal is repeating. 37 over 90. Let's look. Let's type 37 divided by 90 equals 0.41 repeating. Yeah, kind of cool, right? So that's when I would use this technique. I would use it on this. If both number or all the digits are repeating, I would use this trick. Good. So hopefully that helps you. That's a nice little thing that isn't always taught or shared. Number 10, show that the two triangles are similar. By describing a sequence of transformations that map triangles. So we have things called reflection. We have things called translate, which is like a slide. And then we have something called dilating or scaling. We would scale it. So I personally would probably first reflect this over this axis. This axis would be, that equation would be y equals -1. I would reflect it over y equals -1. I wonder if that's what they say. Do they say that? Did they give, yeah. Oh, I wouldn't make it over y over -1, sorry. Because if I reflect it, that's 1 away. That would create, whoa, sorry, where am I? I would not over -1. That was a mistake right there. Because that would make, if it's 1 away from this, you see it's 1 away from the line of reflection, axis of reflection. It would need to be 1 away from here. So I would be creating this triangle, and that's not good. So that's not on par with this line. I need it to be on par with that. So I actually would not do it over that. I'd do it over this, right in between here. That's a half away. So this line I would reflect. So 1 is reflect over y equals negative, what's that, 1.5, 1.5. If I reflect it over 1.5, I get this triangle, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. So I get this object. Now this is good. We're kind of online. And now I'm going to I'm going to translate it. That means move it, slide it. Let's do 2. I'm going to translate. What would we say? I would translate it 1, 2, 3, 4, 5, 6, 7, 8. 8 units to the right. I don't know if you would do this. You might be able to do this. I think that this is proper notation. X, Y to every X, you're going to do X minus 8 comma Y. So you plug in every coordinate, every point on this, and you would subtract 8 to the right, to the left. Mr. Mac, to the left. You were looking at me, why would we do right? I would translate it to the left. That would put it into this position. 1, 2, 3, 4. And then it looks like this. So that translation would look like that. Take every XY coordinate, subtract 8. The Y values would be still okay. And then we're going to dilate it. So we're going to expand it. We're going to multiply everything by, what would the scale factor? What would we do? So show the two triangles are similar by describing the sequence that maps triangle. Oh, I'm doing it the wrong direction. I took the little one to the big one. So sorry. So that's bad, Mr. Mac. So we're actually going to translate first. So yeah, I'm sorry. Let's do this. Let's move this. Let's take that away. Sorry. We're going to move the big one first. So we're going to translate first. We're going to translate, not green, blue. I'm sorry. We're going to translate, and it's going to go to the right. And this time it's going to be x plus 8. So that moves the big one. Let's do this. That moves the big one over. So the big one translated as in blue. 1, 2, 3, 4, 5, 6, 7, 8. That moves it to here, to here, to here. So that's good. 1 is translate 8 units to the right. Then we're going to reflect. Now we'll reflect it. This will be, now we're going to reflect it. Can we move you all the way up? Yep. 1. Sorry, I know this is confusing. Apologize. That's going to be, it's going to be plus 8. We're going to reflect over. We still do it. It's just the order 2. We're going to reflect over 1. So that takes us to, let's do red, reflection. We're still going to reflect. That takes us to this object. And now we got to shrink it. So we are going to dilate it. Let's dilate scale factor. We call it scale factor. So what do I need to multiply to get that? So that point right here is the point 1, 2, 3, 1, 2, 3, comma, 1, 2, 3, 4, 5, 6, 7, 3, 7, right? So that point is 1, 2, 3, 4, 5, 6, 7, negative 7, sorry. And I need it to be 3, negative 6. That's this point, that's that new point. So how can I multiply that y value to get to be 6? So 7, negative 7 times what will give me negative 6? Well, that's interesting. They say a 2/3 factor. I don't see it as 2/3, by the way. Dilate it. Is that really only 2/3 of it? Let's look at, well, let's look at that. That's what's my y going. So this is 1, 2, 3, 4, 5, 6. This is 6, negative 2. And and the new point is going to be 5, -2. So what is that? 5, -2. That's the x. Maybe that's what we do. 5, -2. 6 times x equals 5. Yeah, this is kind of hard. Mr. Mac's not familiar with this dilation part. I am very unfamiliar with it. We are shrinking it from 6 to 5 and from 7 to 6. 7 to 6 and 6 to 5. What would that? So let's do rise over run. So rise over run. So rise is up, down. So my up, down is 7. My run is 6 times what will give me a 6 to 5. Maybe that's how we do it. I like that. It's kind of fun. It probably isn't the right answer, but we'll see. So we multiply by 6/7. No, that's not going to... 36 over 35, blah. So we multiply it by that. No, they say 2/3 with a scale factor of 2/3. Yeah, I'm not necessarily. They scaled it first. Oh, I'm not doing it enough. I did it shorter. I didn't extend it. That's why. No wonder it's 2/3. And Mr. Mac made another mistake. Mr. Mac made another mistake. Sorry, scale factor. I like my thinking. See, this is how we work through things. We're not always going to know. So this is 3 wide, but it's 1, 2, 3, 4, 5, 6 high. So this is not 1, 2, 3, 4, 5, 6 high. Takes us to this, Mr. McCausland. Hello. 6 goes off the chart. 1, 2, 3 goes to here. So this point is really that is 3, 1, 2, 3, 4, 5, 6, 7, 8, -8. Well, look at that. We're shrinking it 2 on the height and 1 on the width. I mean, that to me seems a little bit more logical on what we're shrinking it, unless I'm not counting that right. That's good. That's 1 and that's 2. So rise is 2, run is 1. So 1/2? No, because that wouldn't be 1/2. So this is 3/8, and that's going to 3, -6. And this is going from, that is what we say, that 1, 2, 3, 4, 5, 6. 6, -2. And this is 5, -2. So let's try that other one that I did. So we are going from, let's try that other technique where I did my rise over run. We have from 6 to 5, and we have, that's my run, and then we have -8 to -6, and this times what would give us that. So let's multiply by the reciprocal, which is 6 over -8. 6 over -8. Does that work better? Does that give me, that's -36 over -40, which is, 4 goes into that, 4 goes into this, 9 and 10. No, that's not my number. So if I multiply that by 9/10, no, I don't know. I'm sorry, I don't know how to do the dilate. I would look that up. It says 2/3. I'm not necessarily certain on how you do that. Sorry, that took a lot of time. Let's talk about the mapping here. This one's going to include a rotation. So we are going to rotate it 90 degrees. So we can do one is rotate 90 degrees. That would take us to this. This is 2. This is up, over, no, not over all that, over a partial, and then down into it. So that rotates negative 90 degrees. So that is 90 degrees. We can pick a line. This is how I do it. You pick that, and then you see that it's 90 degrees on how we are rotating. So we rotate it there, 90 degrees. We're going to, let's shift it. Let's translate it, as they say. 2 is translate. We're going to go 1, 2, 3, 4. 4 units to the right. I still like this. This is still a really good understanding. That's good. And then that takes us to here. And 3. 2 units. 2 units. And down like this. And now we have to dilate it. So Mr. Mac is still struggling with the dilation, but let's do dilate. How do I spell dilate? D-I-L-A-T. No double A there. Dilate. And this tells us to dilate 1/2. Dilate 1/2. This was dilate. This said to dilate 2/3. Scale factor. Dilate, we're not going to dilate short. We're going to actually expand it. We're going to make it bigger. Oh, shoot, I did it again. I went from the done opposed to the original. Oh, Mr. Mac, you're really, really driving me crazy, Mr. Mac. Sorry. First, we're going to translate. We'll move it up. I'm going to move it up. Sorry. I know, this is confusing. I should be better. Sorry. So I'm actually first going to translate 1, 2, 3, 4 units up. Up. That's going to be 1. And that's going to be not x. We're going to do to our y plus 4. And then we are going to, we're going to rotate. Then we'll rotate. We'll rotate 90 degrees. So this time it'll be plus 90. So we'll rotate 90. That'll be 2. Rotate positive 90 this time. That makes it look like we rotate around there. That's going to be boop. And this is going to be 4. And then that goes 3. And then it goes like this. So that is a rotation around. If we look at those 2 lines again, you take this and this. That gives us a rotation. That wasn't very good. That gives us a rotation of 90 degrees. And then, oh, now we still got to slide again. Now we got to slide one more. Sorry, before we dilate. We got to go left 2. Now also left 2 before we rotate. Let's before we dilate. That's actually going to be 3. 3 is translate. Left 2 units. So that's x comma y translates to x minus 2y. And now we're on par, so that'll slide it over to on top of it. We'll go, oh, sorry, here, 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 and here. And now we need to shrink it. So we're going to shrink it. Well, it says by half. So dilate 1/2. Okay, let's get let's get away from these. Sorry about that. This is not the best. All dilations, all this is coming from 7th grade math. So in case you are wondering why I don't know it, it's because we don't practice it in algebra in 8th grade. So I am deficient in this, and I should spend some more time. I know the rudimentary aspects of it, so I apologize. Triangle ABC has the vertices A. Let's graph that. Let's get to something that we know. ABC, A is -2, 1, 2, 3, 4, 5. That's point. B is going to be -5, 1, 2, 3, 4, 5, 1, 2, 3, 4. And C is -3, 1, 2, 3, 0. So we have a triangle, and that triangle looks like this. Okay. Good. That looks nice. And we have, let's name it. That is A, B, C. Good. Is transformed to the following ways. First, it is reflected in the y-axis. So it's going to be, this is our y-axis right here. And let's do, it's going to be reflected over our y-axis. So all of our coordinates, our x coordinates, will become opposite. So this is a nice way of doing it, is we say A is -2, 5, and that translates to A prime is going to be 2, +5. B is the point -5, 4, translates to B prime is going to be 5, 4. And then C is -3, 0, and that translates to C prime, which is 3, 0. So we can make those dots, those new dots, and those new dots are going to be 1, 2, 3 right here, 5, 4, 3, 4, 5, 1, 2, 3, 4, and it's going to be 2, 5, 1, 2, 1, 2, 3, 4, 5, and this is going to be A prime, B prime, C prime. We can connect those dots to get the new triangle. And that's our new one. So first is reflected over the y-axis, then it is translated 2 units down and 1 to the left. So what does that look like? 2 units down, oh, sorry. So 2 units down and 1 to the left. So if we were going to write that, that would be xy translates to 1 unit to the left is our x-axis, -1, and 2 units down would be y -2. So we take all of these points, these new prime points, and we say A prime is 2, 5, B prime is 5, 4, and C prime is 3, 0, and we're going to translate, we're going to put it into this transformation. So we have 2 - 1, 5 - 2, and our new coordinate is going to be 1, 3. Let's do A double prime. A double prime is going to be 1, 3. So we put that transformation, 5 - 1, 4 - 2, and we get B double prime is going to be 4, 2. And we do the same thing. Put in our x value, 3 - 1. Our y value is 0 - 2. And we get C double prime equals 2, -2. Wow, Mr. Mack, you knew that part of it. Yeah, I don't know. There's some certain things that I really jive on and certain things that I struggle with. So dilation is one of the things that I struggle with. Let's make this, let's turn this, sorry, I want to start changing some of the colors. Let's do this all in blue. Let's do all these points in blue, so we know which part of the translation we're doing. And now let's make this in green. Let's make these in green because we were using green. Green, good. And now we will plot these points. So A prime is 1. A prime is 1, 3. So 1, 1, 1, 2, 3. So, oh, sorry. 1, 1, 2, 3. Is that 2 units down and 1 to the left? Yes, this is A double prime. B is going to be 4, 2. 1, 2, 3, 4, 1, 2. That is going to be B double prime. And C is 2, negative 2. That would be C double prime. Let's connect the dots. Oh, let's connect them green. I like how that turned. That's to there, to here, to there. That's my next transformation. And now, lastly, it is rotated 90 degrees clockwise around the origin. Okay, around the origin. So here is our origin, and we're going to rotate it. That point, we can sort of do a, I've done this in the past. Let's make it red. Let's make it red. Let's make it dotted. And this is how I like doing rotations. I draw it from here, and then I draw it 90 out. So what does a 90-degree rotation look like? Well, it actually inverts your points. It goes and opposites on your x. So your x, it's going to be, what is it? It's like y comma negative x. So no, negative y comma x, negative y. So negative 3, 1, 2. Oh, let's get our 1, 2, 3, positive 1 right there. And that does look like, notice that looks like a 90-degree. It's kind of cool. So, and you're going to do that for each point. Now we can't, there's just an easier translation formula, so that when you rotate, let's make it in red, sorry. When you rotate 90 degrees, you're going to take your x comma y points, and they're going to translate to negative y comma x. Yeah, so each rotation has a nice template that you can apply. So we're going to use A double prime, and A double prime is 1 comma 3. B double prime was 4, 2. And C double prime was 2, negative 2. 2, negative 2. So if we translate it, we're going to take my y value and make that negative and place it in my x value, and then just move my x to my y. So negative 2, 4, that's 2, 2. And, oh, sorry. Let's move those over so I can show what that is. That's going to be A triple prime, B triple prime, and C triple prime. So negative 3, 1. Yep, negative 3, 1. Let's do my other point, negative 2, 4. Negative 2, 1, 2, 3, 4 is that point. That would be my B. And then my C is 2, 2. 2, 2. So if I connect the dots, making it red, good. Oh, I don't want dotted anymore, I want solid. So if I connect these, connect those, connect that, is that rotated around the origin 90 degrees? Yeah, I'm going to say that it is. Let's go and see. Yeah. If we looked at each point and, well, let's look at the answer. How about that? Mr. Mac? Let's look at that. Here we go. What are the points? Oh, it doesn't say. Is this 14? No, this is 12. Did I throw 12 away? I guess I threw 12 away. Here we go, 12. So the new point is going to be rotation. Yes, 3, -1. 3, -1. 2, 2, -4. And -2, -2. So I did not. It is not that. That is not the rotation, Mr. Mark. -3. Oh. 3, -1, sorry. 2, -4. I flipped it. I messed it. 2, -4, and -2, -2. So it's actually that. So I was close, y, comma, -x. So here I was bragging about myself on how good I was, and I really wasn't very good. So let's take this. We'll just borrow these points for a second. I really like that. That was kind of looked like 90 degrees. So I'm surprised that that didn't end up being the point. The point is actually 3, -1. 3, -1. Oh, 3 negative. We're moving it this way. That's 3, -1. 3, -1. That's correct. The next point would be 2, -4. 2, 1, 2, 3, 4. And we have negative. No, I don't want to recognize it. -2, -2. So let's connect the dots. That still should work. This should still work. Oh, now it's going to be. And I mean, I'm just messing everything up on this. Sorry. Not my best work today. Not my best video. But it shows how much you can't. Oh, that's pretty good. That's 90 degrees still. So that definitely still worked. That this was still 90 degrees. And does that look like it rotated 90 degrees? And sorry, this is a horrible video. This is why it's important. You're not going to be able to get away with just winging it. You got to put some time in. You got to understand it. All right, this I do understand. This one I will get correct. This one is geometry. I'm a little bit better at geometry. We know the sum of the angles inside of a triangle is going to equal 180 degrees. So we know that 52 plus 59 plus that missing should equal 180. So that's going to give me 111 plus the question mark equals 180. Let's subtract 111. And that gives us a question mark is going to equal 69. So this is 69 degrees. We're okay with that. And we can do the same thing for this one, 52 plus 51 plus the missing. So we have this, we have 52 degrees plus 51 degrees plus the question mark should equal 180 degrees. That's 103 plus the question mark equals 180 minus 103 minus 103 tells us the question mark equals 77. Yes, so this equals 77 degrees. That's a horrible degree. Let's make that 69 degrees. And then we should know that the sum of those are going to equal 180. So we will go down here and we know that 69 degrees plus my x plus my 77 degrees should equal 180. That is 146 degrees plus x equals 180. Minus 146 minus 146, x equals 34 degrees. So that missing x is 34 degrees. Yay, I finally got one correct. Sorry, not a great way to start this. Find a value. Again, love these. These are okay. We have parallel lines. This is important for us to notice that they are notating that M and N are parallel. Since they are parallel, we create this transversal. Transversal has lots of equivalencies. That y is going to be equal to this y is going to be equal to that angle. And that y plus x plus 26 is going to equal 180. So that's kind of important. If we want to find what y is, we would take this. So ooh, I see what they're doing. I think I'm seeing what they're doing. Y plus x plus 26 should equal 180. That's a straight angle. We have this angle plus this angle, and these are congruent because they are what's the term again? 7th grade math. They are corresponding. Corresponding angles. Y and this are corresponding angles. Okay, so we know that they're corresponding, so we know that they're similar. So if we want to find out what y is equal to, we just move everything. Minus x minus 26 minus x minus 26. Y is going to equal to negative x plus 154. So this angle is equal to negative x plus 154. Okay, so now we have the three angles. Don't know if you saw that. This is 1, 2, 3. So the sum of the three angles is going to equal 180. So let's add those all up. So you have negative x plus 154 plus x minus 48 plus x minus 7 should equal 180. And the x's, we're left with x. We're left with this, this, and this. So 154 and 7 is 14, 55. 55, so 99. X equals 99 degrees. And then what do they want? They want find the value of x. X equals 99 degrees? Nope. Oh, yeah. X equals 99, but it doesn't say. It says minus that from 88. How do we get 54? Yeah, 54 minus x. X minus 48. X minus 7 equals 180. Oh, sorry. Yeah, plus 99 equals 180. Sorry, we were just adding these to get the 99. Sorry. Equals 99. Now we're going to subtract 99. We get x equals 81, and that is what it equals. All right. Lines M, N, and etc. are going to give us that. I'm giving an assessment to my student who just has one math problem to do.
Thank you.
Good luck. All right, lines M and N are parallel. Find the value of y. Oh, what did we do? Find the value of y. Find the value of y. All right, we found that x equals 81. So it's 81 plus 26, which equals 107. So this angle is 107, and this is going to be its supplementary angle. So that is going to be 180 minus 107, which equals 73. 73 degrees should be our missing angle. Yep, that was easy. Margaret has a spherical glass vase where she keeps flowers. Its diameter is 6 inches. How much water does she need to fill it 2/3 full? Give your answers both in cubic inches and in cups. Okay, so we have a spherical glass vase. Looks like that. Oh, nope, sorry, spherical. That would be a cylindrical spherical glass vase. I'm assuming it has a hole in it. Its diameter goes across. So if its diameter is 6 inches, then its radius is going to be 3 inches. Okay, how much water? So volume equals 4/3 pi r cubed. For some reason I know that formula. And that is going to be the volume of it. Look how easy that was. So we need 1/3 of the volume. So we can do 1/3 of the volume. 4/3 pi r cubed is how we can look at it. We can cancel. Woohoo! They just don't cancel, Mr. Mac. Radius. So volume equals 4/9 pi. And then our radius is 3 inches, quantity cubed. Which, okay, well, we're going to cancel soon enough. 4/9 times pi times 27 inches cubed. The 9 cancels with the 27 3 times. So we're left with volume equals 12 pi inches cubed is going to be our volume of, I mean, what would we call that? Give your, in cubic inches, so that is cubic inches. Some people want to, I'm looking at it, cubic inches. All right, so sometimes they let you have pi, sometimes sometimes you have to do 12 times the pi value, which is 37.7. 37.7. 4/3 pi r cubed, 2/3. Did I not multiply it by 2/3? 1/3. Come on. These are silly mistakes, Mr. Mac. 2/3, which is 8/9, which is still 8, which is 27 pi inches cubed, which 24 times pi equals 75.4. 75.4 approximately inches cubed would be your answer. And then does it say round to? Doesn't say what to round to. And it says a basic calculator. Okay, that's good. We didn't graph it. And then if we need to convert that to cubic inches, we're going to divide it by 14.43. Divide by 14.43 something or other. 75. So it equals 5.2. Yeah. So volume equals 5.2 cups. That's interesting. So 5.2 cups. Good. All right, those are your two answers. Only made one mistake on that one. Hi, not one of my best. Not my best day, 11:58. Lucas is designing a coffee cup in the shape of a circular cylinder. All right, now we're back to the cylinder. Coffee cup, if its interior diameter is 6.2 centimeters, 6.2 centimeters, what should its inner height be so that its volume would be, so it wants to know what H is. So the volume would equal 340 milliliters. Volume equals big B times H. Volume equals, the base shape is a circle, so that's pi r squared. So volume equals pi, we know. Radius is going to be 3.1 squared, and the height is what we're looking for. And we know what the volume is, 340. So let's start simplifying. 340 equals 3.1 squared. 3.1 squared is 9.61. And let's multiply that times, oh, does it say use 3.14 for pi? I didn't read that. Let's multiply it by pi equals 30.2 h. We'll divide by 30.2, divide by 30.2. So let's memory plus, clear. Let's do 340 divided by memory recall equal, oh, why did it become 60? Memory plus, memory, I don't know where, well, memory clear. Okay, 3440 divided by 30.2 equals 11.25 or 11.3. 11.3, what's my units? Centimeters. Centimeters equals my height. Okay, so very important to understand volume, surface area, and all those things. Good. Note 1 cubic centimeter, 1 milliliter. The volume would be 1 milliliter. Oh, did I not? How did I get away with that if I didn't convert it? 1 milliliter is 1 cubic centimeter. So I got lucky. I converted 340 here. So I could have made a huge mistake. No way. All right. Hey, let's get to solving today. Mr. Mac's good with this. Now we're back in the wheelhouse. We're talking algebra. This is an Algebra 1 placement. So apparently there's a lot of geometry and 7th grade material that is on algebra, aka pre-algebra. So let's simplify first. Let's distribute this. You get 10s plus 8 equals 7s minus 2s plus 10. You're distributing -2 to both of those. We're going to simplify the sides first. We have like terms here. That's 5s plus 10. Let's move the variables first. And then we can move the constants to the other side. So we get 5s equals 2. Divide both sides by 5. And you get s equals 2/5. We can leave it as a fraction. Don't feel like answers can't be in fractions. We again are going to distribute. You cannot, the area that most students make a mistake is they subtract. Can't subtract before multiplication. So we're going to distribute the -3. So we get 20 minus 3x minus 12 equals 14 minus 5x. Let's simplify the like terms on the same side. -3x plus 8 equals 14 minus 5x. We're going to move the variable to the left side, which means we're going to move the constants to the right. These cancel, you're left with 2x equals 6. Divide by 2, and you get x equals 3. X equals 3. We're good here. Oh, that's a really good one. So we can make this into fifths. We can either change that to fifths. We can cross product. We can get the x over on the other side and cross product. So I'll do it a couple ways. Let's turn this -3 over 5 minus 5x over 5. That's an equivalency. -5x over 5 simplifies. That's an equivalent. Now we have like denominators, so we can combine their numerators. We get 2x minus 3 minus 5x all over 5 equals 2. Let's simplify. We've got like terms up in this numerator. Negative 3x minus 3 over 5 equals 2. Let's multiply both sides by 5. Negative 3x minus 3 equals 10. Add 3. Negative 3x equals 13. Divide by negative 3. We get x equals negative 13 thirds. Is that really the answer? If it is, okay. 18a, yeah, negative 13 thirds. I'll show you the other technique. I'll show you a creative way to do this. 2x minus 3 over 5 minus x equals 2. Let's add the x over. What? You're moving the variables to the opposite side of each other? Equals x plus 2. Let's make that over 1, and now we're going to cross product. We're going to multiply these two, multiply these two. Yes, wow, how cool is that? 5 times x plus 2 equals 1 times 2x minus 3. So we get 5x plus 10 equals 2x minus 3. Let's move the variables. Let's move the constants to the other side. You get 3x equals negative 13. Divide by 3. X equals negative 13 thirds again. That's a real fun, creative way. That's an efficient way. Oh, hey, look at that. I didn't even know that was coming. So we're going to cross product, and we get something 5 times the quantity y minus 3 equals 4 times the quantity 1 minus y. 5y minus 15 equals 4 minus 4y. We're distributing. Let's move the y's to the left side. Let's move the constants to the other. That's 9y equals 19. Divide by 9. They don't care about ugly fractions. They're not afraid to take a stance. So distribute. 6x minus 1 equals 6x minus 6. Let's move the variables. We're not going to move the constants. Well, we can move the constant. Let's move the constant. I'm okay with that. You're going to get 0 equals negative 5. That's a false statement. When, and so it's no solution. And the thing you have to remember is when the variables cancel, and you produce a false number statement, the answer is no solution. The answer is no solution. No number can make that equation true. Something to remember. Remember, if variables cancel and you get a true number statement, a true number statement, then the answer is all real numbers. All real numbers. That's not the case here, meaning every single number works. Every number plugged in can be a solution. In this case, no number that you can plug in to make that left side equal the right side. That'll probably happen right here. We'll see. Negative 5x plus 1. Let's distribute. You get 6x minus 6 minus 5. You get negative 5x plus 1 equals 6x minus 11. Let's move the variables. Let's move the constants. And we get 12 equals 11x. Divide by 11. 12 elevenths equals x. That's my answer for 19b. Oh, and it says, solve the equation to indicate whether each equation has one, none, or an infinite number of solutions. We have one solution. No solution for A. And here we get 6x minus 12 equals 6x minus 12 minus, move the variables, move the constants. 0 equals 0. The variables cancel. That is a true number statement. So it is all real numbers is the answer, but there are an infinite number of solutions. So any number I plug in will make it equal, will make it true. Landon, hello Landon. How many more we got? Okay, 3 more. We can do that. Boop, boop. How do I make it go away? Boop. There you go. Landon bought 4,500 concrete blocks at $1.35 a piece, but he got a discount on 1/3 of them. Of his, if his total came to 5,000, find how much the discount was. So, on 1/3 of them, well, okay, well, I mean, you can make this a whole lot, but you got a discount on 1/3 of them. Well, does 45500 times 1.35, I mean, wouldn't you just 6075 minus 5775? No, wouldn't that tell you the discount? Minus 577, 5775. Wouldn't it just tell you that you have a $300 discount? Am I reading it incorrectly? How much, find how much the discount was. I mean, if the blocks, and then 1/3 of them at a discounted price, I mean, are we going to do way too much more work than you think we're going to do? I already paid. That's such a bad wording. Okay. So you have 4,500 concrete blocks, and they're going to be broken. So you got a certain number at, so you got a certain number. Let's find 1/3 of this. So 4,500 divided by 3 gives us 1,500. So 3,000 are going to get priced at 135, and then 1,500 are going to get priced at a discounted price, the discount cost. Okay, and then the total is going to be that. Let's erase this. It was poorly written, but technically they're telling me that the pieces that I purchase are 135, and then this is going to equal my 5775. So 3,000 times 2 is 3,000 times 1.355 gives me 4050. 4050 is the price for the undiscounted bricks. And then I have 1,500 at the discounted equal 5775. Let's subtract the 4050, subtract the 4050. We get 1,500 blocks times that discounted price is going to equal 5271, 1725. And then we're going to divide by 1,500 blocks. That's my cost for all the blocks of the discount. This is the cost of the discounted, 1725. So if I divide 1725 by 1,500, we get 5. So the discounted blocks are going to cost $1.15 a piece. So the question says, oh, how much was the discount? Now, so I would do, okay, I got it. So 1,500 blocks, undiscount, non-discount, without discount, would cost me, how much was each block? Each block is what, 135? 135. So you do 1.35 times 1,500. That would be my normal cost for that, $20.25. However, my discounted blocks cost me $17.25. And yeah, $300. I was right. Minus $17.25, and it is $300 discount. I don't know what they want here. I mean, I got it the first time. That was very interesting. What do they say? The discount was 20 cents per block. Okay. Yeah, 20 cents, 135. Okay, good. Yes, we knew that. In other words, he paid $1.15 for each of the. Yeah, I got it. Okay, I knew that. I could have just done 1,500 divided by 300 and found the discount. Watch this. 1,500 divided by 300 tells 5 cents. No, well, I don't know. That was a 5 cent? No, it's 20 cent discount. I don't know. I got it. The sum of 4 consecutive whole numbers is 2,342. First number is x. Second number is x plus 1. Third number is x plus 2. Fourth number is going to be 3 away from the original number. One, 2, 3, 4x plus 6. We're like terms, and then constants equals 2, 3, 4, 2 minus 6. 4x equals 2, 3, 3, 6. Divide by 4, divide by 4. And 4 goes into 2336 evenly. 584. So my first number is 584. My next number is 585. My next number is 586. And my fourth number is 587. What are the numbers? So we would write it in this fashion. 584, 585, 586, 587. Solution set. I like those. Price of an item is reduced by 27%, and then a 6% sales tax is added. You paid $34.82. What is the original price of the item? So we have the price is reduced by 27. So we're going to multiply price times 0.73, because that would be reduced by 27, and then we're going to add a 6% sales tax. That is 1.6. So this would be the price plus the sales tax, because we want to add both of them, and that's going to equal 3482. This is a really good problem. This is a problem more students should be able to understand. This comes with a lot of experience. So we get 0.73p equals, let's do 34. Can I get you small? Can you get smaller? No, you can't get smaller. 3482. 3482. No, I'm not going to. 34. 82 divided by 1.06 gives me, that is so ugly, 3284, and then divide by 0.73 gives us 45 bucks, 45. Price is $45. So price volume is reduced by 27%. So we want 45 times 0.73. 0.73 gives us 3285, and then times the sales tax of 1.06 should give us 3482. Yeah. So the price is, did we get it? Did we get $45? And that's some crazy number that we divide by 0.73. 0.73, 0.73, and we get $45. That's such a silly problem. All right, time for lunch, 12:20. Kids are coming. I got afternoon classes. This is completed part 1. How many problems did we only do? We did 22. How many pages, though? How many? 48 pages of work. All right. Thanks for your patience. Hopefully you were able to understand some of the nonsense that I put out there today. Apologize for the dilation and 10 mistakes that I made throughout today. It happens. Nobody's perfect. You're going to get math problems wrong. You can't be perfect. Can't hit hole-in-ones in all 18 holes. Good luck.